three panelists. So, and today's webinar is on industry applications and the associated risks in terms of radiation. Basically, we are focusing on applications which have radiation risk. So we have Engineer John Shege, one of the panelists, is here with us. Collins Umondi is also here with us. And I think Kamau he might be having some challenges connecting with us. So each of our panelists will give them 10 to 15 minutes to just make a presentation. Then we'll have some Q&A sessions. So if you have any question as the presentation is ongoing, you can post it on the chat. And after all the presenters have made their presentation, then we'll be able to pick some of the questions and move from there. So we are going to start with Engineer John Shege. He was the first person here. He was trying the system early enough to make sure that he doesn't get locked out. So, asante sana engineer for heeding to our call. So, you have 10 to 15 minutes to make your presentation. So, I'm going to project your presentation on the screen. A minute. So, I hope everyone can be able to see his presentation. So, and just a request, make sure when you're not talking, you have your mic muted. David Kahia, please mute your mic. So I'm also going to mute mine as well. Yes, so engineer, the floor is yours. So I'll be turning my mic off.
Yeah. Thank you very much for inviting me, and this is a very special moment for me. First, I want to say that I'm very grateful to be on board here with some of the people who go all the way back to early 80s when we were starting the NDT committee in the country. David and even Kamau, who we are yet to receive, were some of the very people who actually joined me then, starting the NDT committee. But for this period, the world is facing this COVID-19, and this year, the world NDT community was to meet in Seoul, South Korea in May for the World Conference and the International Committee on NDT, the General Assembly, but had to be cancelled because of this health challenge to sometimes next year. And we are hoping that it will happen. I can say this has challenged the industrial actors in the application of radiation and associated testing methods, and particularly the NDT sector. And even locally, as you know, we have restrictions as to what time you can go to work. And as you know, for industrial service providers, they have to move out into the site. So it's a very difficult time for us. But we believe that things will come back to normal, and then we can move on. I want to just bring some historical information which sometimes has been lost over the years. Industrial application in the country started with some government organizations such as Kenya Railways, Ministry of Works then, the Kenya Bureau of Standards, the University of Nairobi, we had the KQ, and very few of the people in the private sector. But this was the engine that drove the industry application. And I want to say this without anything left, is that as a country, since coming together as a NDT committee and changing ourselves to NDT society, we have seen a lot of progress in this area. I can say that for all the NDT activities that have happened in the last 20, 25 years in this country, it has been done by local people. We owe a lot of it to training that has been offered by various institutions and development partners, and particularly the role of International Atomic Energy in training our personnel in the area of industrial application is one that has been very key to development of industrial application in this country. But Kenya has played a great role in promotion of industrial application. And I remember way back in 1994, this country was the one that hosted the first African Region NDT conference in Nairobi. In fact, other countries like South Africa held the second one before even the North African countries took over. But Kenya has been active in the International Committee on NDT. There has been some missions of technical papers to various world conferences. And I remember myself having presented one in '89, another one in 2000, which was on effects of bombs after we had the terrorist attack in 1998, and we had to use various methods for checking the stability of buildings in Nairobi. So as a country, we have been active, and I am very happy, like the role that various organizations have played, like Radiation Protection Board, the Nuclear Center, many other organizations that over the years, we have seen many, many more people trained and acquiring specialized training in various sectors. And as a country, I can say that we are there. And we may not be talking much about ourselves, but even when we dream of putting up nuclear power generating plants in the country, one area that I am very confident that Kenyans can play a great part is in the area of inspection. And I think we have invested well, and the Kenyan people have taken this area seriously. So I know that in all this, it has not been easy because as a country, we don't have capacity to either manufacture or sometimes service some of the equipment that are involved in industrial radiography. But I can see a lot of progress within the country, both in the private sector and also in the public sector. But we still have challenges, particularly when it comes to sourcing or recharging the isotopes, because we have to ship them out and get them back. Sometimes they may not even be brought in time because sometimes we have urgent work, but we can't have turnaround for the sources to come in time. So that is a challenge. The other challenge, of course, is calibration, sometimes repair, and as a country also, it costs us quite a lot to be able to sustain this sector. We know that this sector is important, but we hope that as the country moves, there will be people who invest, whether in the public or private, to ensure that there is an infrastructure to support the industrial application. For many of our, particularly the sources, including the isotopes, particularly when we have to go out to do work, the issue of where they can be kept safely, how they can be transported from one area to another has always been a challenge. And not everybody takes all the precautions that are necessary. And for us, I think is something that we need to discuss and establish which is the best way to ensure that if it is a source moving from one point to another, it is taken care of, it is guarded, it is monitored, and even where it is kept, it is safely verified that it is safe, and that has been an issue. I know the regulator has been there providing certain services, but sometimes I believe they are not equipped to undertake this particular role because of the number of the people who work under them, and also the challenges that are there now with an expanded county government and national government. Sometimes there is a need to ensure that that particular important law is not lost. We also have to be careful because not everybody cares about this country. There are many people who may sneak or bring in those isotopes, and when they get depleted, the issue of disposal sometimes is not taken care of, and that is something that also, as people concerned in this sector, I think it is so important for us to make sure that nothing comes in and it is not documented or properly known how the disposal has been executed. I think it's something that we all need to work together, and the safety is an issue for all of us. Just like we are dealing with the virus today, any problem associated with the radiation should also be an issue for all of us to safeguard. And I believe we need to make sure that in when you're dealing with safety, we also have to make sure that we provide adequate safety to the people who are providing the service, particularly the radiography, and even more important also to ensure that wherever we are working, the environment is also safe for others, because sometimes, particularly in the industrial application, we may find ourselves working in areas which are high density, places where maybe if it is a pipeline is passing through a game reserve, and informal settlement, and it is important because sometimes it's so hard to educate people as to the need for them to move away to safe distance. So a lot of public education is important for people to understand the problems associated with exposure. And for us doing this work, we must also make sure that we are not driven by money only. We have a responsibility to be people who even care about the other people. And for that matter, it is important that all the stakeholders, particularly where projects are to get into areas where, other people may be affected, that we must also bring awareness to them, and they must be brought on board to make sure that whatever is being done safely. I think on matters of unregistered sources into the country, I believe there has been gaps. I believe that we cannot just leave this area not fully protected, because we know that even after the accident in Japan, and that it was also possible for certain vehicles to come into the region, which had excessive exposure to radiation. And for this reason, it is important that the gaps that exist in terms of verification of what comes in, how we survey, how we monitor the utilization of the sources, particularly how and who is actually handling them, the licensing. It is an issue that is of great importance to all of us. And I think there should be a lot of emphasis, a lot of cooperation with all the various stakeholders. And in this area, I would like to bring on board the people who work in various government institutions, whether it's the Minister of Health, Minister of Labor, Occupational Health and Safety. Whether
Engineer, you try to be a bit quick. Almost the 15 minutes is over.
I'm almost finishing. So
okay.
For me is that it is important that when you're discussing this matter, we all have to bring all the stakeholders together so that we harmonize the various registrations that are in place and enhance them to make sure that we promote industry applications, and in doing so, we do it safely. Thank you very much.
Thank you very much, Engineer. So to those who are maybe joining us now, you can post your question. We are going to have a session of Q&A after all the panelists have made a presentation. I'm glad to inform you that our third panelist also in the house, James Kamau. James Kamau, are you in? I saw you joining.
Right.
Yeah, so our next presenter will be Collins Omondi. Collins, are you ready? Collins, as we give Mr. Kamau time to organize himself. Collins, can you unmute your mic?
Yeah. Okay.
Yeah. So should I project your presentation, or you're going to do it from your end? Collins, I can't hear you. Unmute your mic.
Hello?
Yes.
You should
yes, now I
project
can hear you.
my presentation.
Okay.
Yes,
Okay. Engineer, please can you unmute your mic, and James Kamau?
Yes.
Yes. Mute your mic, please, so that you don't have feedback. I'm getting some feedback, and I can see your mic is on. Engineer's mic is on as well. Nanga Margaret, yeah. So please unmute your mic. Dennis. Yeah. So Collins, you can be introducing yourself as I load your presentation.
Thank you. My name is Monty Collins. I work for Kenya Bureau of Standards at the Secondary Standards Laboratory, and welcome to this presentation.
So I'm trying to load your presentation. You just give me a few minutes.
Okay.
So I'm having a challenge with your presentation, Collins. Engineer, Mr. James Kamau, is your presentation ready as I re-download his?
Yes,
Okay.
mine is ready.
Yeah. Are you able to project? You can try projecting.
Let me try. Yes, I should be able to. I think I
Okay,
will.
although, yeah, Collins' presentation also came up, but okay. But it's cannot open. Just project yours as I re-download Collins' presentation. It's not opening.
Can you see mine?
Yes, we can see it.
Do you want me to continue?
Yes, yes, proceed. Do you have 15 minutes? It's 6:06. I think we've lost some times there. But you,
Thank you.
if you take 10, you still appreciate. Yeah, so proceed.
I'll try my best. Thank you very much for your invitation in this discussion. I would like to introduce myself. My name's James Kamau, ex-Kenya Airways, but currently working for myself as an NDT specialist in Wilson Airport. I work for NDT Support Services, whereby we give aerospace operators NDT services. And now I would like to take you through on how we make use of radiation in non-destructive testing as far as aerospace industry is concerned. There are a number of NDT methods that we apply. And it happens that radiation is one of it in terms of radiography. But I would like to give an insight on what we normally do in aviation so that you can be able to come up with a good comparison of why we have to use radiation. We do penetrant testing, magnetic testing, eddy current testing, ultrasonic testing, and radiography. That is in number 1 slide. If you go to the next slide, you'll find that there are particular areas that we apply NDT. And that is aircraft materials, structures, and components. And in these areas, we do use X-rays and all those other methods to look for flaws or defects which are surface or subsurface. Now, in order to do that, I would want now to change from the other NDT methods and concentrate on radiography. On the radiography, we have got equipment that we use. And since what we are looking for is how we use the radiation safely, I would like to touch on starting from the equipment, how we ensure that the safety starts right from the time we buy our machines. We buy our equipment, that is in aerospace industry, from specified manufacturers. And those equipments are X-ray machines and Iradium-192. Although there are other isotopes in use, the main isotope that we use is Iradium-192. If we go to the next slide, I will give on how we control the equipment in order to enhance radiation safety. Our equipment in aviation, irrespective whether they are gamma rays or X-rays, they cannot be removed from their safekeeping without a register. They have to be registered by the user, indicate where they are being taken and what they are going to be used for. and the time. And there are two ways of controlling those equipment. One, for the X-ray machines, they are kept in a safe custody, either in a locker or in a tool store. For the gamma rays equipment, those are the projectors, they have stricter controls. One, they are kept in a safe custody, which is constructed purely for their safekeeping. And the isotopes are kept in their projectors at all times. They are never removed. And the safekeeping is controlled by a radiation safety officer at all times. And the safety officer keeps the keys both for the housing and for equipment, so that whoever wants it would get it from him, and he ensures that he knows where the equipments are being taken and for what usage. If we now look at our slide number 5, I'll be demonstrating how we continue controlling those equipments. In aviation industry, we have what we call approved data. And those data, they are standards that we use at all times. And they come in form of manuals, service bulletins, airworthiness directives, and service letters. They indicate how and where and what kind of strength is required when we are carrying out a procedure. And this applies to both X-rays and gamma rays. So if we go to the next slide, slide number 6, it will be indicating how we are supposed to be approved in order to be able to use those equipments. We use standards that are already laid down as aerospace standards, which is EN 4179 and NAS 410, which specifies how the personnel should attend approved courses and should have how they should be examined and the experience required, and at the end of it, what kind of certification they would attain in order to be able to use isotopes and X-ray equipment safely. Those equipments, before one is able to use it, he has to be a level 2, approved, certified level 2. And on top of that, the personnel is supposed to have a basic safety training and an examination carried to ensure that he can be able to take care of the general public and the other NDT personnel who works around them. If we go to the next slide, you will find that there are so many challenges that goes with the training or the challenges that we get in order to be able to get to that level of attaining a certificate in level 2. The training is not locally available. It can only be conducted overseas. And most of it will either be done in the US or in the UK. And it is very expensive because you consider flights, you consider accommodation, you consider tuition, examinations, and the time off out of duty. The experience required for the NDT personnel to be able to attain that license goes as much as 1,700 contact hours. And these hours has to be documented and certified by another qualified level 2 or level 3 inspector. Short of that, one cannot get a certificate even if he is able to pass the exams. The other challenge the radiographers get is, even after training, the employment slots are very few. Reason being, there are very few facilities that practice aviation NDT in Kenya. And as such, there is a requirement that those who can be able to open up other facilities should join us, those who are out there, so that we can join hands and be able to create more jobs. On our slide number 8, in order to mitigate this, NDT Society of Kenya was formed some times back. And the purpose was to see whether personnel can be effectively be trained so that the industries can get practitioners and they can get trainers and get auditors so that the safety of NDT is enhanced. So in the next, our next slide indicates the benefits of being able to join that society so that we can be able to work together hands in hands as NDT specialists. As we all know, even other industries other than aerospace industries do not have enough NDT personnel. So the moment the society is able to coordinate the training and certification, we will be able to get more NDT practitioners. We will be able to get NDT trainers who are not there now. We will be able to get quality control managers. We will be able to come up with our own regulations. And that way, we will create jobs and the industries will benefit by having professional workers and their business will be enhanced, thus improving the safety in all the industries, irrespective, whether it is industrial, whether it is railways, whether it is oil and gas or aerospace. And with these regards, we require support, or we require to support the society as individuals or corporate members or industry key players, even the government. And that comes to the end of my presentation.
Thank you very much, Bana James. So make sure you keep putting your questions in the chat. So we'll have the last presentation and then we'll go into Q&A sessions. Okay. So our next presenter is Collins. Now I have your presentation ready. Sorry for the hiccups. So let me just project it. So you have 15 or so minutes, and then we'll go into Q&A. So I hope you can see your PowerPoint, your slides.
Yes, thank you, Bwana Cairo. I can see it. I'm presenting from my phone. I think you'll help me to scroll it. So welcome to this presentation. The topic is standardization tools for radiation industrial application. Next. Next, Bwana Cairo. So industrial application has a long history. It started all the way from this man Röntgen in his laboratory, and he invented this radiation application. So the initial application was use of radiation through X-ray tubes. This did not help industries because there's a lot of breakage. So until the General Electric came into the field and modified the initial invention. Then around the 1930s, there was need for NDT work for the site work. So this necessitated the need for radioisotopes. So the first radioisotope used was iridium 226. Then after the First World War II, there was the use of cobalt 60 and iridium 192. This early application had a lot of challenges. The first one was the application sometimes takes 4 days. These are applications that are currently taking 1 day. Cairo, next. Mr. Cairo, the next slide, please. So the current one slide previous, or the previous slide, Mr. Cairo. Mr. Cairo, the previous slide. So this is the current applications of radiation, and we have nearly all sectors of economy, be it security, be it in healthcare, in construction, in manufacturing. It's used protection of arts. Nearly all sector of economy has some form of industrial application. Next, Cairo. Next slide, Mr. Cairo. So the kind of radioisotopes that are used in the industry are several. We have cesium-137 for food irradiation, cobalt 60 for cancer therapy, iridium 192 that are used for americium 241 that is used mostly for detectors, as seen in smoke detectors. Different applications uses several types of radioisotopes in the industry. Mr. Cairo, next slide. If you look closely, the number of accidents that occur in the industry in comparison to other sectors, the industry leads in the number of accidents. Currently, the accident in the industry is 48%. Nearly half of these accidents happens in the industry. Therefore, there should be industry. The medical sector is slightly lower than 9%, and other sectors are less than 5%. Mr. Cairo, next slide. Next slide, Cairo. If you look at the accident by source, most of these accidents occur using iridium 192. This is because iridium 192 is used for site work. So during radiography, there's a lot of accidents using iridium. This is followed by cobalt 60, which is about 29%. Next slide, Cairo. So the IEA did a lot of research on the causes of this accident, and they range from equipment maintenance, calibration, qualification of personnel, safety procedures, monitoring, training, human error, safety programs, mishandling. All these some of them are recorded in the IEA safety series report number 7. Cairo, next slide. Next slide, Cairo. So the solution to these industrial challenges lies with the quality infrastructure tools. We are talking about metrology, testing, accreditation, standards, and certification. If you take, for example, a system for certification or accreditation, it involves auditing management system, quality systems, looking at documentation, procurement process, conformities, issues of maintenance, both preventive and corrective, financial, accommodation, sampling. All these challenges that occurs in the industry can actually be handled by the quality infrastructure tools. So let's go to the next slide, Mr. Cairo. Next slide, Cairo. So at Kenya Bureau of Standards, we have several departments that try to address these challenges. We have a department that deals with trade, metrology, testing, certification, and pre-export verification. And lastly, on quality assurance and inspection. Let's just look at some of these departments on how they can solve some of these challenges. So Mr. Cairo, next slide. So we have the first one known as metrology. This is basically the custodian of Kenya national standards. So here we have several facilities that carry out calibration. It could be on pressure, temperature, mass, density, viscosity, time, frequency, energy. All these parameters that affect the industry could actually be tested and calibrated by this metrology department. Next slide, Mr. Cairo. The department that deals with the radiation activity is dosimetry, and you can see this is a trend all over the world. We have about 97 such dosimetry facilities in 67 countries. Each country has a designated facility for dosimetry application. So in Kenya, this dosimetry facility is available at Kenya Bureau of Standards. Next slide. So at KEBS, we have this dosimetry facility that is, its main mandate is to develop and maintain national standards of dosimetry equipment. Currently, we have two facilities. We have an X-ray laboratory and cesium 137 laboratory. We have a third laboratory of cobalt-60 that is being upgraded. So our current capability is a calibration of radiation protection equipment that are used in the industry. And also we have a capability to carry out diagnostic equipment. Next slide, Mr. Cairo. So in terms of accuracy at the primary level, which is can only be realized by, I think, 5 countries, US, UK, Germany, France, Italy, and Austria, and Canada. The accuracy of this measurement is at 1%. At the secondary level, where the Kenya Bureau of Standards is, for radiation protection equipment, where the industry falls, the range of equipment is within 5%. At the user level, where the application is, the equipment expectation is that they should be within 20%. So we carry out this calibration to check whether these equipments work within those specifications. Next slide, Mr. Cairo. So these are some of the equipments we're talking about. They could be of different manufacturers, different models. It could be a survey meter, ionization chamber, a TLD, a gigamolar, any kind of equipment that measures radiation must be tested and checked whether it works out properly. Our recommendation is that this equipment should be calibrated every year and be given a certificate. If it is not working properly, it should be issued with a report and therefore be taken for repair. Next slide. The other facility that we have is NDT. In this facility, we use any of the 6 methods: visual testing, penetrant testing, magnetic particle. But the one that uses radiation is radiographic testing. Here we have 2 laboratories. We have a gamma lab and an X-ray laboratory, mostly used to check the wells, whether they have defects or no defects. Next slide. The other program that we have is a quality assurance and inspection. This program ensures that items that are manufactured within the country are in compliance with Kenyan standards, and from the country of origin or of the country at the entry, to check whether they are within the required level of standard. Next, Rafael. Next slide. So in terms of product certification, we have several, but just to mention 4 of them. The first one is Diamond Mark of Quality. This is given to a product that has a long history of excellence. Then we have another one, Standard Mark. This is for a local product that has been tested, and the results are within the required standard level. Then we have another one known as ISM Mark. This is for a product that come from outside or imported and are checked against the Kenyan standard. Then lastly, and which is the most important one, is the calibration mark. This is for equipment that has been calibrated and the results are within the required parameters. Next. Next, Panakairo. The other department we have is standards development and harmonization. They've done more than 8,600 standards, and in the East Africa region, you have about 1,200 standards. So developing a standard is a process. First of all, there's a proposal, then the committee has to sit, do some deliberations. Then the output goes to the public for review and for comments. Then it goes to balloting, finally approval, and a publication. Any standard that is of interest to this sector can be expressed to us. Then we'll take it up, form a committee, and it can be reviewed and finally undergo the whole process and eventually to publication as a Kenyan standard. The next slide, Mr. Cairo. So as a finish, the principle of radiation protection also applies to the industrial sector. The principle of justification, that means the benefit must outweigh the risk. The principle of optimization, the use of as low as reasonably achievable source. And finally, the personnel working within this environment must not be exposed beyond the required dose limits as prescribed by the regulator. To help in this dose management, we use we play around with time. You spend as minimal time as possible, keep distance, be as far as away from the source because of the inverse square law, and radiation shielding. Sometimes mostly use concrete or lead. Next slide, Banakairo. So for the 2 facilities, we have 2 projects funded by IEA in this current financial year. The first one is on dosimetry. It aims to span the scope to include mammography measurement, computer tomography, dental, and radiotherapy. The second project, that is multisectoral, aims to establish a system for education, training, qualification, and finally certification of NDT personnel. This is a 4-year project that is currently it's 3rd year, and it needs to solve a lot of problems that are in the NDT, specifically on qualification and certification. Next slide. Lastly, as a finish, it's important to emphasize that any equipment that is used in the industry or medical application should try to ensure accuracy and traceability. Thank you for your attention.
Okay, thank you very much, Bwana Collins. Now that's bring to an end the presentations. Now, I don't know, from my end, it seems I've missed some questions which have been posted by some of you. Maybe Dr. Toma will help me. I only have 4 questions, which are all directed to Engineer Kirago, but I've seen in the WhatsApp post a question directed to James on NDT. I don't know, Daktari, are you there? Dr. Toma? Yeah,
Yes,
just
I'm
maybe.
here.
Okay, it seems like I'm missing some of the questions. Would you be kind enough to pick some of the questions? Because I only have 4 questions from my end. That's what is appearing from my screen, my chat screen.
Okay, I have all the questions.
And you are breaking.
So maybe a question from Nyachege. Nyachege, you're still there?
Yes, I can still, he's still around. Huh? But you need to unmute your mic.
Yeah, I'm asking Engineer Chege, you're still there?
Chairperson, I suggest that the one who wants to ask the question can write it so that Engineer Chege can actually follow the trail of the question.
Actually, they are already.
Hello. Can you hear me?
They are all written, so normally we don't ask all of them, we pick a few. So maybe this is a question which.
I can hear you.
We can hear you.
I can hear you.
Yeah, solution to you, Engineer Chege.
Yes, David.
Our support is this on the application of standards in ND as a basis for acceptance of results.
Standards.
Yeah, what is your view on the adoption and application of standards in NDT as a basis for acceptance of results?
Okay, that's one.
Yeah, just deal with that one, and then we'll hear also from Engineer Kamau, and lastly from Engineer Collins.
If I got you, you're asking what is my
view
on standards.
Yeah, on the adoption.
Yes, one I must emphasize that globally NDT is a very commercial activity, and in most cases when we are doing NDT work, we have to meet the client's requirements. And sometimes the clients will specify the acceptance standards or criteria. So in most cases, irrespective of maybe what a wish of a service provider, one has to meet the specified standard. For example, if it is oil and gas, the API 1104 specifies on what is acceptable and what is not acceptable as per the standard. And for me, in terms of adoption, like in Kenya, for example, if it is an issue of oil and gas, the easiest route is for us to adopt what is globally accepted as a leading standard for acceptance or rejection of a particular product or application in a certain sector. Hello?
Thank you very much, Engineer. Could we have the view from Engineer Kamau and also Collins? What is your view on the adoption and application of standards in NDT as a basis for acceptance of results?
Yeah, James Kamau is responding to that. And I would like to support the view of Engineer Kiragu, because that's exactly what we do in aviation industry. Right now, we are drafting our own requirement through Kenya Bureau of Standards. I'm sure as we speak now, Collins might be able to respond to this. And what the Kenya Bureau of Standards have done is to get hold of EN 4179 and customize to fit our needs. Generally, as Engineer Kiragu has put it, we are guided by certain standards and they override all that we do. The only time we evaluate using our own experience and knowledge and skill, it's when we are doing an impromptu inspection which is not defined. At that juncture, we can use the standard practice and evaluate, and our clients have no reason to doubt the results. Other than that, as Engineer Kiragu has put it, we have to use a certain document which is normally presented by the client. We do not give our own documents in NDT. It's the client who comes with the documents and says, this is the job that I want you to do for me, and this is the guidance. That's my reaction to that question.
Thank you very much, Engineer Kamau. Collins, for your take on what is your view on the adoption and application of standards in NDT as a basis for acceptance of results?
Of course, I support the use of standards because in the absence of standards, probably you could be using a procedure for the manufacturer or a manual for the manufacturer. But the standards takes care of the manufacturer, the user, and the investor, and the public. This is a negotiated document between all these categories of people. So we support the use of standards. In cases where some parameters might be outside.
Hello? Collins? I'm losing Collins.
All of us, you are losing him.
David?
I can hear you.
Yeah, Collins is blinking. Eh?
That's true. Collins, just fix your internet while we go to the next question.
Need.
David?
I can hear you, yes.
I just wanted to add one small thing. As we talk of standards, let's also not forget that there is a major component of qualification and certification of personnel carrying out the NDT work. And over the years, the biggest challenge globally has been the harmonization of the qualification and certification schemes. Like Mr. Kamau has already mentioned, you have aviation, we had the scheme like the ASNT, the ISO. Globally, there has been a lot of fights, if I may call it, to try and bring all these procedures to a common platform where people can recognize each other. Because the problem is that, like Mr. Kamau, if he is working on a Rolls-Royce jet engine, maybe G may have a different requirement. And sometimes, even if you are qualified in one, you find yourself not acceptable in another one. So I think even as we discuss this matter, one of the biggest challenges, and it was going to be discussed in the World Conference this May, unfortunately until next year, is the progress we are making in the harmonization of qualification and certification of NDT personnel.
Thank you, Engineer. So while you are still on that, yes. I would like to hear Engineer Kamau and Collins take still on that, but this is the way to go about it. Coming back to Kenya, many years ago, before Kenya Bureau of Standards was in place, we had the Ministry of Public Works, currently the Ministry of Infrastructure, Roads and everything. So in the Ministry of Public Works then, we had the Material Testing and Research Laboratory, which actually had both destructive and non-destructive testing. And then after 1971, Kenya Bureau of Standards came into being. And right now, as we are talking, Kenya Bureau of Standards has a fully fledged NDT laboratory. Now, going forward, many of our people who have trained in level 2 and level 3 used to go to South Africa and go to USA and other countries outside Kenya. And actually right now, as I'm talking to you, Sudan has an accreditation to train people to level 3. And we have a challenge in our own country as concerns the requirements for a training and certification scheme for NDT personnel. And this challenge, we've tried to go about it this way. We've tried to convince Kenya Bureau to be a certification, not Kenya Bureau, the NDT Society to be the one to certify, and then Kenya Bureau to be the one to test. And then when it comes to training, anybody can train. So long as you have level 2, for example, you can certify level 1. If you have level 3, you can certify level 2 and 1. So can we discuss the requirements for a training and certification scheme for NDT personnel in Kenya? I would like to hear first Engineer Kamau, and then Collins, and then back to Engineer Chege Kiragu. Thank you.
Chairman, afterwards, maybe I'll have a word.
Let's hear those panelists first because they offered to come.
Thank you very much, Dr. Otoma. Qualification and certification of NDT personnel is a very big challenge, not only in Kenya, but worldwide. However, in Kenya and Africa at large, we are disadvantaged because as we speak now, we have only a few of training centers which are recognized in industrial NDT. But in South Africa, we have one center which was recently certified to train and certificate NDT personnel. The rest of Africa, we do not have certifying bodies on aerospace NDT personnel. Now, Dr. Otoma, you suggested that level 2 can certify level 1. Unfortunately, because we have to adopt a document which is already written, or on all the documents that I have gone through, there is none that picks that certification system. The system is such that level 2 can sign off the work for level 1 in terms of experience. Even level 3 cannot certify unless the the level 3 is from a training center which is already qualified to train and certify. Hence, the challenge still remains. I know we had started, and Engineer Chege, I'm sure he's likely to have an input on that. We had that foresight sometimes back, and we faced a few challenges, and we could not move very far, including now. In about 4 years ago, we had South African trainers who came to Kenya Bureau of Standards to train personnel in view of gaining certification on the relevant field. But unfortunately, because of the experience, the personnel who are trained, as much as they passed the exams, they could not get their certificates because they didn't have the relevant experience required. So in whatever we do, the buck stops with experience because there aren't many companies capable of giving that experience which is required. That withstanding, we have a challenge which I am sure we should be able to go around it in the very near future because we are putting up a document together to see how best we can address that challenge.
Yeah.
Over to you,
Dr. Collins, your take. Looks like Collins, the rain is in his area, so he's not online. So
now, David, if I may,
Hello?
Hello?
Hello.
Can I add to?
Can I make some contribution?
Oh, okay.
Please go ahead, Collins, before you are cut off again.
Okay, in the issue of NDT certification, currently we have an IAEA project for 4 years, and the project aims to establish a system for education, training, qualification, and certification, which is a big challenge for this country. Last year, we had an expert from Morocco. He visited the NDT stakeholders, and we agreed that the 5 institutions should take a role. For example, the University of Nairobi, under this project, is going to take the teaching role. The Kenya Bureau of Standards will set up an examination center. The NDT Society will carry out a certification program, and KIRDI will do research and development on NDT. And lastly, NAS will help in the accreditation of NDT personnel. So by the end of the 4 years, we shall solve the system on education, training, qualification, and certification if we achieve the objective of this project. Thank you.
Thank you, Colin. So, Engineer Kiragu, you can have the second last word.
Yes, I think unfortunately, as in Kenya, we don't seem to be moving. We seem to be rotating. If you remember way back, David, and you were, when we started the committee of NDT, you are taking care of the safety, if you remember. And
yes,
then,
I remember in 1996, but a child born in 1996 is now 4 years old.
I'm just saying, when people mention Morocco, Egypt, and all that, South Africa, they forget how much as a country we have been doing things. The only problem with us is that we don't seem to move. What Collins is saying is something that was agreed maybe 20 years ago. But the problem, and we must agree, is that from the time Ministry of Public Works, Material Plans, started fighting with the Kenya Bureau of Standards. We got stuck. Yeah, you remember the NDT Society was housed in a material branch, and then Muriuki took over as the secretary, and then things just stopped. What I would like us to do is to remember that you cannot have a simple way into all these things. Right now, those people who follow the American system, it is based on employer certification. That means as quality inspectors, if we train and we make sure that that person can perform, we certify that person, whether it's a level 2, to be able to perform. But where the world is going is a central system where the ISO 9712, if I use it, is that we want to put people in a way that we can have a central certification. And that's what I think Collins is looking at. However, it is something that you cannot do overnight, because even if you got certified at the Kenya Bureau Standard, for example, and I have a contractor on site who is doing a power plant, and he says he wants another certification, they will not take our local certification unless ours is recognized at another level. But what I think, and I have heard is important, if we can agree that we can create a certification center, and it doesn't need much. All what we need is independent examination, independent specimens for people to be examined on. And the challenge for us over the years has been the cost of fabrication of those kind of specimens that you may require. Otherwise, in terms of personnel, we can designate, for example, like our chairman there, that he belongs to the training. We pick another person who is as qualified, who becomes an examiner. But in terms of infrastructure in the country, we have enough. What we don't have is a common mind in moving this agenda ahead.
Thank you very much, Engineer, for taking us along memory lane and saying that we have a habit of chasing the way a dog does its tail. Maybe there's a gentleman from Kenya, his name is Masinza. Masinza, yes. You are there, or the child is crying? It looks like he's fighting with very many sons.
These are the challenges of staying at home.
Okay, I'm here. My acting last born is in PP1.
On requirements for training and certification scheme for NDT personnel.
Thank you, Chair. Can somebody mute his mic, because there's a child somewhere who is making noise.
Chair, somebody by the name Dixon. Dixon, maybe please mute your mic.
If you can just do that. Okay, thank you. Chair, thank you very much for this opportunity. I want to start from a point of agreement with Engineer Chege. Engineer Chege, I think if I met you, maybe it was a very long time ago when I was working at the Radiation Protection Board, long ago. But I can say, maybe you don't remember me.
No, you have grown bigger.
I even had a beard last week, a COVID beard, but I shaved it. Now, I wanted to say, first, I have to agree with you on one thing, that we seem to rotate and not move. That is a very, very powerful statement. So after this, immediately after this seminar, Chair, with your permission, we will need a way forward, even if it means having a fora, just another webinar, just to discuss what does it take to establish a quality system that can ensure the training and certification of personnel in Kenya. I would be willing to be part of this because there is a lot. The second thing I want to point out also from what I have heard is that there is a project, Ken 1006, which is putting in so many players, University of Nairobi, KEBS, it even has listed KENAS. But I want to tell you now that KENAS has never been officially approached, has never been officially engaged on this. or seized of this matter or the opportunity. So, first, Kenya has been established as an accreditation body that is recognized worldwide through the system of ILAC and IAF. And we provide accreditation services for those who carry out testing, be it general testing for products and other materials. We also provide accreditation for testing that is in the medical realm. Like currently, most of the labs, almost 80% of the ones doing the COVID testing are actually accredited labs. We also have accreditation for inspection bodies. And the word inspection has been used a lot in the NDT lingua that has been used a lot in the presentations. So we actually are ready and capable of providing that linkage. What Engineer Chega has mentioned that's very important is that even if we have a self-declaration say by an employer that you are level 1 or level 2, that is good. In fact, it's a very good starting point. But the issue of acceptability of results across boundaries, because we will not be working only for a pipeline in Kenya or for an industry that is operating in a confined environment. You are going to go across borders. Your results will be required by clients who are not necessarily in Kenya, and therefore accreditation provides an avenue for this kind of anchorage. That means acceptance of results across borders without question. So, Engineer Chega, I agree with you when it comes to recognition. The issue of use of the 9712 standard to designate level 1, level 2, and level 3. ISO, being an international organization for standardization, I think used experts like yourselves to come up with a standard that can have uniform application all around the world. And therefore, it is actually a standard that determines the competence of a person. It gives requirements for someone to be designated as level 1, or to be designated as level 2, or to be designated as level 3. I think this is a discussion for another fora, but I just want to put it together this way. First, in order for us to have a national or otherwise a qualification and certification scheme in Kenya, we require that the certifier be accredited to a standard called ISO/IEC 17024. I know engineer is certified and others on this forum. The organizations that certified you had to be accredited in order for your certification to be accepted worldwide. That's number one. Secondly, the CB, the certification body that we are creating, if it is the entity society, it has to recognize the training centers. There's a formal agreement or recognition that it gives to ABC to be a training center. It also recognizes what we call an examination center, or has a mechanism for ensuring that the examinations are conducted in accordance with procedures so that they can be accepted. I am not lecturing here, but just to say that I have on occasion attended meetings at the International Atomic Energy Agency, where the technical officer, who is also responsible for this project, Ken 1006, has always asked me, what is the progress with regard to the qualification and certification scheme in Kenya? I have reached back to Kenyans who are actually in charge of this project and who are implementing the project. The truth is, let us say it as it is, and I can say it even in broad daylight tomorrow, we are rotating and not moving. We need to move. This project has a lifespan. The lifespan is moving so fast. I think Collins said it is ending in, let me just check my record. Collins said it is ending in 2022.
David.
Hello?
David.
Yeah,
Hello?
you could summarize. You know, you've taken 7 minutes, and that I was thinking you'll take 2 minutes.
I'm sorry,
David,
but I was trying
can I
to
comment a bit?
bring on board the fact that if at all we are serious about establishing this system, then with the way we are going, the project is going to end and we will not have a national qualification and certification scheme. Thank you.
Hello,
Thank
David.
you very much. I would like to return the meeting to the chair
David.
so that the chair
Maybe I
can
can add,
close the meeting because it's already past 7.
David.
However, you are welcome to continue staying and chatting and talking if you so wish, but I will stop recording because now the talking will again start going round and round. So the chair, please, you take over, close the meeting so that I can stop the recording. But you are welcome to continue being present and ventilate. Thank you.
Before you close, I just wanted to bring one issue, only one issue. With your
No, I'm not closing. I'm not closing. I'm taking the meeting back to the chair to close the official session, but you can continue. I will not lock you out of the meeting room. I will let you continue even up to 9, if you so wish.
Thank you, Dr. I think if this debate can continue on and on. And I think some of us had some other meeting. Actually, I have another meeting which is supposed to start at 7. So probably,
to ask,
yeah.
Chair.
Yes.
I just want, for the benefit of all of us.
Yes.
For the benefit of all of us.
Yes.
For NDT worldwide, there is International Committee on Non-Destructive Testing, ICNDT, and we should be visiting their website, and particularly the matters of standards, qualification, and certification. And all those things are there. And this is an international body that it is dedicated, and Kenya is a member, to guide us in terms of formulating and implementing like what we are discussing today. So mine was that as we go forward, can we also be visiting what ICNDT has already put in place, and it will be so easy for us to implement like what we are saying, because things are already there, and it is a matter of getting and adapting them, and then we make a move in the country.
Yes. Thank you, engineer. I think we need to organize another forum and continue the debate. Otherwise, I would like to thank our panelists. Sorry, we are not taking any more contribution because of time. We're supposed to end at 7. Actually, we have 8 minutes behind the schedule, but we are going to organize for another session. Actually, you can give us some of this feedback to our secretary. Her email is available on the flyer that we had circulated, and then we'll organize another forum. And actually, from the discussion, we agree that we've been moving round and round in circles for over 30 years. So otherwise, I would like to thank each one of you for taking your time and joining us here and making this debate lively and important to each and every one of us. For our panelists, we are really grateful for finding your time even to off your busy schedule to prepare something and to share with us. So I would also want to thank our Dr. Toma, for providing this platform for us to converse. So at this point, I want to declare that the meeting is officially over. But as Dr. has said, we can continue to engage each other. It still remain open for discussion, but our recording will end now. So thank you very much.
Thank you.
Thank you too.
Now,
so you
whoever
may
had some
continue now. I'm
contribution
not
can continue
recording.
now.
Yeah,
Yes,
I'm not
now the
recording now,
contributions
so you
can
can
come in.
ventilate.
Hello.
But you pick your own moderator, or so that you don't talk to each other.
David,
Yes, Mike.
David,
Hello.
you owe me a cup of tea
Hello.
with the Kamau.
Hello, can you hear me?
Engineer.
Hey, Mangala, I can hear you.
Oh,
And
yeah, I am.
Engineer Chege is saying I owe him a cup of tea with Kamau.
Can I make a comment?
Yes, we do.
Yes, you
We
can
do.
make many comments now. Now it is open mic.
But
Our
even
that
if
years or so,
Engineer Chege, who
it's
owes
about
us
time we
a
had
cup of coffee.
Odia, there's so much uncoordination that I'm not audible now.
You have to agree who's going to be the moderator so that he tells everybody to keep quiet and want to talk.
Okay, but I think what is happening is that for sure, and it's well known that we are working and moving towards establishing a qualification and certification system in the country. And I'm sure, I think
Maybe you could introduce yourself so that people who don't know you know who you are talking, Prof.
Oh, okay. My name is Michael Magala. I'm the project coordinator for the IEA project 1006 on establishing a system that would coordinate and for establishing a training and certification center of NDT personnel. So our project actually has been in existence for the last 2 years, and I think we are left with 1 or 2 more years. And to date so far, we have had some visits to put the structures right that would be acceptable to provide those services